So assume that we have an entity called book, and the attributes of this entity is or are authors, title, publisher, genre, and price. We define them. Here, besides data modeling, I want to give some information about relational databases, but I want to give it with some examples. So we defined author, title, publisher, genre, and price as attributes, and the book is the entity name. So in annotation, one of the notations, the design is, or the entity is shown like this in this box. Instead of giving a table view, you can represent it like this. Be familiar with that. So here, that's nice, that's good, we defined it, but I think we have a problem. Why? Let's go on with some examples. Assume that our boss wants us to update the data. I believe that you can easily do it now. He wants or she wants us to update the book Cloud Atlas price to 15.1. It's 13.6 at the moment. I want to increase the number, okay, the price. That's okay if you have only one of these books, but there can be other books with the same name. So there's also a book from David Mitchell, and its price is different at the moment. Which Cloud Atlas do I want to update? This is an important question. So, okay, then let's change or let's ask our boss to update its query, and now it says the price of Liam Cullen's book is updated. That's nice, because if we have two books, one of the author is Liam Cullen, so it is updated. That's nice. But what if the same author has another book too? What can we do now? It is very hard. Which one to update? So assume that's okay. Then now let's give a statement in more detail. Let's say the price of Liam Cullen's book Cloud Atlas is updated. Okay, the book, Liam Cullen's Cloud Atlas. Now it's okay. I can update it to update this value. It seems okay. But for a moment, think about what we did. We started with a query. Then in a situation it didn't work, so we changed it. But in real world, it doesn't happen like this. When you send the query, it updates it, and no one asks you like, okay, I updated two books. Is it okay for you? No one asks you something like this. So in this situation, if you have two Cloud Atlas and if you execute this query, then for sure all the prices are updated to 15.1. That's for sure. No one asks, no one tries to correct you, okay? So we must be very careful. It is nothing like you write a query and it gives you, oh, I'm mistaken, I don't understand what you say, can you repeat it? No mechanism like this, okay? So each of these examples create false data. But still I want to go on with my example. Okay, I went from this. Okay, assume that Liam Cullen has changed the publisher. What can you do now? In the previous example here, this SQL was okay because there was only one Cloud Atlas from Liam Cullen, but now it is not like this, because it also has the same book was also published from Red House Trade. What can you do now? How can we define the row? Now remember, our problem here is to define which row to update. This is our main problem. First we said we tried the title, then the author, then author plus title, then author plus title plus publisher, etc. It goes on like this. But we can never be sure about we can define whether we can define the row or not. Because when you write this SQL, line columns cloud atlas, we believe that we had only one row about it. But then we see that there is also another row. So we cannot be sure with our SQL statement. So what we need? What we need is a specific column that we can use to identify each row. We need a column like this. And in the data modeling part, we didn't consider this because in real world, maybe we don't have an ID like this, but we need it for a safer data in our database, to keep our data and databases efficient. Okay, so after defining these attributes, we create a new attribute just for identification purposes. Okay, and generally this column has a name ID, or if the entity name is book, then it can be book ID, and this is very common. And the technical term we use for this column is primary key. So it's a key because it opens the locks to each row. Okay, so we can define a primary key is one or more columns of a relation that is or that can be used to identify a row. So the problem we had was identification of a row, and we can use a primary key to identify each row from the others. Remember the times, if you can, that we didn't have this Turkish ID. And before that time, identifying each one of us was very hard, because you can have the same name, you can have the same surname. So people generally asked your mother's surname, things like this, because it is very hard to identify people with names and surnames only. You need a certain number or a certain column that you can be sure that you are not confusing the person or confusing the row. So primary keys are very important. And sometimes you can have more than one key if the situation is available. For example, here PK stands for primary key. When you see two columns with PK next to them, it means that these two columns come together to form a primary key. Okay, author is not a primary key by itself, title is not a primary key by itself, but when they come together, they create a key. Of course, this is not a good key because, as I said before, the publisher may change, but based on your application and your requirements, you can find situations like this. So in some cases, it can be useful. But this application is more popular. Creating a new column is more popular because hard disk costs are very low today, and you are for sure 100% sure that you can identify the one row from the others because you have a certain column for that. And this column is managed by database management system. It controls if a number repeats or not in that column. So, for example, your university IDs are unique for you. So each student in Istanbul Technical University has a certain university ID. So this is a primary key for you. Now let's take a look at this example. Assume that Ayşe bought these two books. Now this part is about the books. Now I'm going to sales part. Ayşe bought these two books. What we will do now? Okay, so you can keep the data just like this in an invoice data table. Okay, you have the date here, customer here, author, Cloud Atlas, etc. I think the name is misspelled, but no problem about it. So you can have something like this. You can have a table like this. But if you keep the data in this table, you can come up with the anomalies that we talked before. Each time a customer buys Cloud Atlas, for example, you write its name again. You write the publisher again. You write the genre again. You write the price again. Okay? But you don't need to, indeed. Why you don't need to? Because keeping this data in new columns costs you some place in the hard drive. So it is unnecessary resource spent. What you can do is very easy indeed. Since we have these primary keys and assume that primary keys are used for reaching each row, when I say David Mitchell's Cloud Atlas, let's say Ayşe bought David Mitchell's Cloud Atlas, I can use it with these words. Ayşe bought the book 2, because I can see that book 2 is David Mitchell's Cloud Atlas. That's so simple. Okay? So instead of writing Lime Cullinan's Cloud Atlas, I can say Ayşe bought book number 4. So simple, because book number 4 in books table refers to this book and the other one refers to this book. So easy. So we can, instead of keeping the data like this, invoice table like this, we can keep the same information, the same content, with a very small table just like this. Date must be here because you need the sales date, the customer data, you need the customer's name, and you need the which book she bought. So instead of keeping all this data, these 5 columns again and again, we can use the ID to represent this data, and from this perspective there will be no anomalies because the data will be in different tables. And when Ayşe bought these 2 books, we can, this is the original books table we had, and when we have invoice table like this one, I mean we only stored these 2 columns and the ID of the book, then we can use the join function or the joining property of relational databases. In other words, we can join these 2 tables and create a view just like this. As I said before in the earlier content, that this is what the meaningful view is. Okay, this is the meaningful view, but if you keep it like this, you have the anomalies and it is inefficient. So we keep data in separate tables, but by using SQL, we join them and show it as a whole to the user, so that user does not need to bind these two rows, etc. So here what we do basically is we used this ID, which is a primary key in books table, as an attribute here. Here it is not a primary key. It doesn't define anything. It just shows the other table's row. It is not, this is number 2, but it is not like the 2 we know in maths. It just represents this table. So if you have a column which holds data which is primary key in another table, this is called foreign key. This one. So we use primary keys to define each row in a table, and we also use it in another table to refer to that row. In this case, it is called foreign key. Okay. So a foreign key is a primary key from one table placed into another table. This is the formal definition. So what we applied here can be represented with these boxes. So invoice entity here, book entity here, and we have invoice ID as a primary key here and book ID as a primary key in books table. Book ID here is a foreign key. It is for binding these two columns. Okay. This time this is called the foreign key, and this foreign key is very important for relational databases. We use them to build relationship between tables, and this is how relational databases can be used to model everything in the real world. Okay, you can have e-commerce website, you can have accounting software, you can have ERP, because by joining tables you can model nearly everything. So let's give another example for joining tables. Assume that we have 3 tables. We have the student table here, we have the course table here, and we have the enrollment table here. Primary keys can be used as foreign keys. So assume that this is the foreign key and this is the primary key here. By binding these, using these two columns, you can bind these two tables, and you can use course ID to bind these two tables. So this table is joined with this table and this table, and the result can be something like this. So S1 Ayşe, phone numbers comes from this table, email comes from this table, course ID comes from this table, CRN comes from this table, and course code comes from this table. So when you design the database with primary keys and foreign keys, you can join any number of tables, and the joining operation is done by the relational database. You just write down simple SQL commands, and the rest of the operation is done by database management systems.